Hey, Jav.
Hey.
Hey, you get to sit with me on my awkward first 5 minutes of recording and silence. No, it's all right. Henry's here. It's fine. Hey, Henry. Hello, let's go back. So, awesome. So, welcome everyone. In fact, is there anything anyone would like to demo?
I don't have anything to demo. I got distracted yesterday with release management tasks, and I was hoping to do some improvements on the HPA configurations for both Nginx and API, but I just got too distracted to really put some effort into it. So I'm going to spend today and do that, and hopefully I'll have something fun to show for next week.
Awesome. Okay. Yeah, no, I appreciate release management's full-time job. Cool. So, couple of things I had then. So yeah, API service migration. So yeah, I was just thinking ahead of the group conversation next week, like whether we saw any like nice benefits on deployments, but like Jav, you're about to crush my hopes.
Yeah, I don't think so. We can take a look, but I assume that web is taking the same, if not longer than API, or was taking longer than API. So it is still a long poll.
Do we know, like, would it be possible to get something on just the API stage?
Yeah, we could compare the time it took to deploy the API fleet versus the time it takes to do the Kubernetes job, which I assume is like, I didn't look at how long it's taking now, but Scarbeck, correct me if I'm wrong, but it's still around like 30 minutes, right?
Oh, I have no idea. That's why I asked you that one question about where because I know we store this, but I couldn't generate a chart. So I want to look at that as well. I'm concerned that Kubernetes takes longer because we deploy to all 4 clusters synchronously instead of
Yes,
asynchronously rather.
To change that. Yes, let me actually do that. Not to change it. Obviously, that'd be a terrible idea, but to open the issue to change it.
Yeah, we need to change that.
We did some testing, and if we're looking at just the API, it takes less than 10 minutes to complete a deployment per cluster. And that's from the start and the stopping of the deployment happening. Now this testing was performed prior to us upping the grace period termination window because of the issue we had with Workhorse. So it's probably longer. I just haven't looked into it since. So
okay.
But in terms of what takes the longest in Kubernetes, it's going to be the Git fleet, because we have a termination grace period of 260-ish seconds, I believe. So it takes forever for those pods to finally cycle through. And if you're ever browsing the Google console, it's almost guaranteed that you're going to see the little warning sign next to the Git deployment because of that precise fact. Anytime we scale down, we wait so long to get rid of a pod. But that's expected. So we know that's happening. That's just a fact of life at this moment.
Okay, makes sense. Do you want me to open an issue for this? Like, I'm literally wondering if we can just get like some numbers and a nice graph, but if it's easier for me to put that in an issue, like, and also I should say, if we don't get to it, that's also fine. We have group conversations every month, so if we don't get to this task before next week, that's fine if we can push it into the future. But open an issue. Cool. So clean up and tech that stuff. So super, thanks for the ideas. Graham did a brain dump, and Scarbeck, you've got ideas. Henry, if you have additional ones, feel free to also just drop them in here. one thing I was kind of relieved about is actually when I went through them, we've got a lot of overlap. So that was reassuring in that we don't actually have like 20 things we want to do. They actually converge quite well. There's like cost saving stuff. There's observability stuff, Helm logs, and the Nginx ingress stuff ahead of web were kind of the big themes I think I saw. Now, I chatted to Graham earlier about this already a little bit, but I guess the challenge is going to be picking the stuff that's going to make web easier and also being able to actually complete enough of it in June to actually feel like this was worthwhile. So how do you think, like, would it be useful if I drop this into a spreadsheet and we do a similar kind of ranking thing like we've done previously with OKRs, and literally try and think like, what's the smallest useful iteration, and this goes towards cost saving or, you know, like web or whatever. So we actually get a bit more visibility of what these tasks are. And then we could each just go through and say like, hey, I'd love to do this, or it'd be super if we had that bit, and then we can see what comes out near the top.
I think that's a great idea.
Yeah. Okay, awesome. I will do that today. So that we've got that, and then we've got the APAC k8s demo tomorrow, so we can run through it with Graham as well in that time. Awesome. Okay, I'll do that. But I think these were all great things, and I think there's definitely some stuff which it looks like we can make good progress on in June. So
we just need to keep track of the items that we've already marked as production blockers as well, because I didn't list any of those in my list.
Yes.
So I'm pretty sure. I know we've added a few.
Great point. So what is happening with those is, hang on, I'll copy these into the agenda after. I've just got to open a different meeting agenda. So I raised 3 potential blockers in the multi-large working group on Monday. So one was the workhorse graceful shutdown. This has been prioritized by source code for 14.1. Now I'm hoping they're going to do it early in that milestone so that we'll get it early-ish July. But they are going to prioritize making that change. So we will get that. The second one I raised was around the Nginx ingress, which Graham's also been working on. We asked distribution to have some input into that, which they have done already. Now, Graham's got a bunch of ideas, and I asked him this morning to rewrite that issue into like a problem statement and a proposed solution, because I think he's at the stage where, depending on some assumptions that he's made, he has a good idea. But I think if we have that clearly written out, it'll be quite easy for everyone else to pile in. So he's going to do that, and we'll see if we actually have a way forwards for the Nginx ingress. And then the other one was around the environment variables, and needing to set those as environment variables versus being settings, application settings. So we talked about this a little bit. And what we're going to do is open these all up as issues in various development teams to get these things moved into application settings. So in the short term, distribution are, they've implemented the proposed method for environment from file. Maybe I should copy this whole chunk actually, then I don't have to read about this. So they've already done the short term, but that doesn't help us in the super long term, because it still means we have to like mess around with things. So I don't think it'll be too big a problem for web, hopefully, but it's certainly not the long term that we want. So they will all become application settings. So at the moment, those things are all moving along neatly, I'd say.
So regarding the EMV from file, that is specifically for the situation we ran into where we're having what I thought was secret data that was being populated. That's not necessarily the configurations that we could only set via environment objects.
Okay.
Either way, I think we're fine, because realistically, what needs to happen is that we need a configuration built inside of the GitLab product itself. I don't think that blocks us because we have this available to us. But
Right,
long term,
exactly,
really,
yeah.
the product needs to be handled in a much better fashion. And that when that happens, that'll bubble up to distribution to add the necessary configuration inside of the Helm chart, and then we can leverage that at that moment in
Right,
time.
yeah.
So short
that's
term, yeah,
true.
we're perfectly fine on this front. I think at this point, we just need to pull the tech.dat item to pull the configuration we did the way we did and push it into a secret as we desire.
Cool. Okay, yeah, that makes total sense. Great, that sounds good. And as we come across any others, or if we suspect there are others that we want to investigate, or we find out are definitely looking like they're web blockers, feel free to let me know, because one thing we're seeing, I think, like for that workhorse one, is the most clear is because we raised it on Monday, the 14.0 milestone had already been started, so it automatically gets scheduled. 14.1 was the earliest we could schedule that into that team. But even then, it's a little bit like, well, we have a lot of other stuff. So, the teams are scheduling 1 to 2 months ahead. So, if we become aware of anything, give me a shout and we can get those in front of development teams. Awesome. Okay. Henry, over to you.
Yeah, so today I looked into the issue that we want to enable action cable on the web fleet, and if that could have any kind of impact on the web fleet if we do this. And the background on this is that we want to enable the real-time assignees feature, and for that we need to use WebSockets, and we accomplish this by using action cable. And what we have running right now is a dedicated fleet of WebSocket servers and Kubernetes, which is nice, which will deal with the traffic for real-time features. But to enable the feature in our web fleet, like make this really happen, we need to enable action cable also in the web fleet, which will just mount the necessary Ruby types and will not run any workers, because the traffic will be routed to our Kubernetes fleet. But this is the only way to make it enabled. So we enable it on the web fleet, but don't use it there because the traffic is going elsewhere. So we wanted to know, does this have impact like increasing memory, CPU, or something like that? And from looking into that, it doesn't look like we get into any problems there. And I just wanted to get more eyes on that if I maybe missed something, that I see Jav already also looked into this one. The only thing I'm a little bit uncertain about is if we really enable this one and we get more requests at the scale of GitLab, that will also cause more Redis requests and things like that. So this is not really a problem for the web fleet then, but for the feature as is, if you enable it. But alone for the web fleet, I think we should be fine from looking into that one.
Awesome.
Maybe I'm slightly confused, but why do we need to enable action cable on our web virtual machines if they're not going to be handling these requests?
I am not sure. I asked myself this question, but I think this action cable is a framework where you get the server and client components. And I think the client component is, I guess, JavaScript that the clients then get down to do the action cable connection. And I guess our web servers are just...
So this is a feature flag of enabling. Okay, that makes sense to me.
And it's
this is just telling the client to do the work.
Yeah, so it's a little bit more complicated. We've got...
I guess it's just strange that we need to enable a feature when we don't actually use it on the nodes, but I guess it's just because this framework makes it easy to enable the client part this way. I guess that's the reason why we do it like this, but I'm not really sure about this.
It's
so realistically, we need to be looking at the WebSocket deployment and evaluating what impact that is going to have, because he's going to be the one responding to those requests.
Yeah.
So there are details in here.
So what's happening is that we have a feature flag, and that will be set to enabled by default. And as soon as we add the action cable configuration, it will be enabled on the web fleet then. So this is a change from the behavior before.
Yeah, maybe we can see if there's a percentage rollout for this on the feature flag, and we can turn off the feature flag before we enable the environment variable. Otherwise, what we could do is we could set the environment variable on 2 or 3 nodes first, and that will make it so that only 5 to 10% of traffic, or we could do it on Canary, right? Do it on Canary first, and then go from there to make sure we don't add extra load to our WebSockets deployment.
We will add extra load. I think right now WebSockets sees so little traffic. It's at the bare minimums for pretty much everything.
Yeah.
Yeah, but I see
Last
a
time I
few
looked at it.
thousand requests, right? I mean, it's doing something already, but I'm not sure how much it will add then if you enable this.
Yeah.
So this is the more important questions actually, yeah.
So there have been various, like the Canary one's a great point. Yeah, they have yeah, so it's been tested on the 10K architecture. It was inconclusive in the margin of error. So, but yeah, Canary sounds sensible. So awesome. I will find the issue that goes with this one, which is the actual setup to enable, but let's do it on Canary. Brill, thanks for doing that, Henry. So is there anything else anyone wanted to go through today? Is there like, I know we're just doing the tidy up, right, for the API service, right? I saw you removing, did you remove the VMs, preparing for removing VMs?
I've got merge requests out there ready for review.
Awesome.
And I'm pretty excited about one of them because that removes a whopping 90 something objects out of Terraform. So, Terraform be slightly faster. I think that'd be pretty cool. But the removal already happened for deployer and patcher. So no deploys are happening on the API fleet anymore. So yeah, and then once I finish that up, I'll just be going through the rest of the epic to figure out what needs to still be completed. Because I know we've got some documentation updates that need to happen. I'm actively working on tuning the HPA and resources.
Oh, yes.
Configuring for these objects and such. So it's chugging along, just kind of slower because of recent deployment related or
release management, of course. Yeah, it's like the busiest couple of weeks. So yeah, that makes sense.
Yeah. I would love, since we do have a little bit of time, I'm curious as to what Jarv may think about tuning requests and limits. Like right now, we're limiting ourselves to CPU memory for determining how far we're saturated or how well things are performing, but I don't think that's the right metric we should be using to scale our workloads. And I say that because we know that there can be an upper limit on, say, CPU usage because of how Puma may work. It can't take but so many worker threads and deploy so many available. It can't use but so much CPU based on how many threads that's going to be spawned by Puma, right? Memory is going to be kind of bound by the type of request it's handling, but none of that says how far we are saturated. We are using saturation based on what we currently develop, based on what we configured inside of our resource requests and limits, which doesn't make sense because that's not tied to the workload associated with, say, Puma. Like we're not saying we're 100% saturated because all 4 Puma workers are doing work. We're saying we're saturated because we're using 1600 millicores of CPU. And I think that's a little bogus. It's not an accurate measurement in my opinion. So when I was looking at the Nginx ingress yesterday, I don't think we have a good view into what we could constitute as what is saturation and how to fine tune that HPA appropriately to ensure that we're not harming ourselves. I did terrible job explaining that. My apologies, but I'm still
So
learning how to do this in general.
so my so what did we, if we're talking about Nginx, what did we do so far?
The only thing we
just up-
changed so far
Mhm.
was bumping up the memory HPA to 70%. That's all we've done so
And
far.
and after doing that, did we see? Oh yeah, I remember you said like the number of pods is still at the max, so that didn't change, right?
Yeah. But the fun part was, because of that change, we lowered the amount of pods that Canary uses from its max of 100 down to 12. So we know it has a positive impact, but you know, the CPU usage is still terribly low. Like it's not using any, every pod is using less CPU imaginable. It's like less than 100 millicores. That's nothing.
Mhm.
So I still think
So
we're very over provisioned. So our HPA is not scaling properly. But right now, based on the conversation we had yesterday, we were going to tune the memory request. After doing
yeah,
some very dirty math, if we tune that value up to 99%, we'd still be maxing out at 100 pods
hold on,
because our
hold on.
memory section
99 memory requests of 99%. I don't know what you mean by that. Like you mean
tuning.
utilization at
Yeah,
99%?
yeah.
Okay. So yeah, I don't think we should do that, but we should, I think, bump the memory requests up to something much larger, and that should reduce the number of pods, right?
Yeah, I just don't know what to set that to is the problem.
Um, I don't think
Like I
it.
don't have a baseline. I don't have anything to compare it to. So I don't know what a pod can handle. I don't know what our nodes can handle.
But can't
Well,
we do some
memory.
very basic calculation? Like if we just use 10% of CPU, that means we can use, let's say, 10 times more. And so we could, roughly said, say we request 10 times more memory to reduce the amount of pods to a tenth, right? I mean, I wouldn't go that far, but something like this. Maybe just go with 5 times as much so that we have more alignment on CPU utilization. That would be a rough rule of thumb, right?
Yeah, I think so. I've got two concerns. One is I don't know the appropriate way to tune. And you know, this is a good discussion about that. But the secondly is like when we come time to defining what we tune, it's trial and error. And it takes forever to get through the process of let's create the merge request, let's evaluate, let's revisit. And, you know, that
Mhm.
the lead time for all that's excruciating.
Would be so cool to have some kind of simulator for this, right? That would be great.
Did you look? So you said on Canary we were running at 100 pods on Canary, and then
We
that
dropped down to 12 after this change.
immediately after the change.
Yep.
And Canary should give us a good idea of like, are we still memory bound on Canary, or does it look like did our CPU utilization go up
I'll have to
on
look
Canary?
because when I was looking yesterday, I was concentrating my efforts on the main
Uh-huh.
stage. So I didn't look at that specifically. So I'll have to do that.
I guess the concern would be that if we take our memory requests, which is at 500 megabytes right now, let's say we change it to a gigabyte. We go like we double it. I guess the risk there is that we'll reduce the number of pods, and then we'll be consuming more CPU per pod with fewer nodes. And then we'll like blow out the amount of CPU that we have because we're not doing any target CPU utilization. We could, I again, like I'm not 100% clear on what Kubernetes does if you have both target CPU utilization and target memory utilization specified. If that works like you would expect, then what we could do is we could say, keep the target CPU utilization at like 70%, memory utilization at 70%, bump the memory requests to, I don't know, like a gigabyte. And then if we become CPU bound, I assume the target CPU utilization will save us, right? Like it will, that's, could we do this? I guess do it do it on like Canary and one cluster, and that should be safe, I think. I would
Yeah.
only do it on one cluster though. I wouldn't do it on all three.
I agree. I guess my concern with that though is like, what is the saturation goal that we're aiming for? Because if we're looking at only CPU usage, it's going to be based on the amount that we've requested. And I don't think that's fair because Nginx could theoretically use as much processing power as necessary to perform its needs before something else breaks.
Yeah, but we need to make sure we're not at max pods. So like and 100 pods seems ridiculously high. So to me,
Agreed.
it sounds like our requests aren't tuned properly. I would start with, like I said, since it looks like CPU is very low, memory is high, double memory, keep the target CPU utilization like what it is at 50 or even maybe I would say 60 or 70%. And then we can observe what happens to the number of pods. But I think that should be safe to do. If CPU utilization and memory utilization do what I think they're doing, right?
Yeah.
Okay.
Okay.
That's for Nginx. What about for API? What did we do yesterday again?
The latest change was to modify the amount of the threshold for the HPA. We changed it from 1600 millicores as an average across all
Right.
pods to 2200. And I have not
Yeah.
evaluated that yet this morning. I've been
Okay.
reading up on various blog posts and published data from other people about how to tune HPAs and stuff. So I've been trying to read up and learn.
Yeah, I think, and I was going to do this today, I just didn't get to it, but to have a timeline in the description, which has each change and a count of the number of nodes for Nginx, I guess the default pool for API, like the zonal pools, and the number of pods so that we can kind of see, those fluctuate. I'm sure it's going to fluctuate during the day. Maybe we can pick a time and, you know, or at least link to Thanos graphs that can get us the information quickly.
I put some of that in the issue description,
okay,
but not as clear to define as you just described. I just put like links to the Thanos charts that I'm primarily using for evaluation monitoring.
Yeah. Okay. Well,
but I can improve that section to add timeline as to like when certain changes occurred.
Yeah.
It'd be good
Ultimately,
to have that thread is becoming long.
Yeah, we may also want to state what our goals are, which I like to think is like, I don't know how many nodes are acceptable, but I assume it's no more than like, we shouldn't go more than 20% of what we had before for the Git fleet total.
Yeah, realistically, I would agree. Realistically, I would love to see us running the same amount of Puma workers per node that we had, since the node sizes are precisely the same, right? And then see what we need to tune to drive down compaction a little bit more and see if we could tune it even a little better to get closer to 36 nodes overall. Right now, we can't stuff more than 3 web service pods on any of these nodes just due to the CPU configuration right now.
Right. Yeah. Okay. Well, I think like our pods only have 4, it's 4 workers per pod, right?
Correct.
Yeah. So
we should try to increase this if we can.
Well, yeah, I think
because I think with the containers, you will not see the memory sharing that is possible if you run the same process space, right? So we will use memory efficiency if we don't have the workers in the same container, I think.
I mean, we did a lot of analysis on this for the Git HTTPS migration to determine like how many workers per pod. And like we landed, I think initially we landed on 2 And then 4, and when I did my testing, like I was seeing problems going more than 4 at the time. So we need to reevaluate that. If we really want to go up to 16 workers per pod, we're gonna have to do some testing to see whether that's okay.
Yeah, sure. I mean, I don't know what other effects we see there, but just from calculating numbers, if we are bound by memory, then the way to be more efficient is to just do as many workers as we can into the same process space.
Yeah, but I think if we do that, then we need bigger nodes, right? Because I think there's just like a lot more going on our C2 nodes in Kubernetes than there were on our C2 API nodes in the VM land, right? And
Graham's raised the point on this about like
one of the to use tainting.
Yeah, he's suggesting that if we prioritize the tainting work, then we would be able to, in his word, pack our nodes tighter and increase cost savings. It's like a marketing slogan. Yeah,
I mean, I'm just generally concerned that even if we do that, we have daemon sets that are running on the Kubernetes nodes that we weren't running on the VMs, and like we just have a little bit more running on Kubernetes. So keeping the node size the same between VMs and Kubernetes, I think, is dangerous if we have the same number of workers. But the whole idea of using, you know what I mean?
Don't need to get to the extremes. I mean, we can just try to double the amount of workers and see.
Sure. Yeah, we could go. Right? We could go to 8. We could go to 8 and see. We'll of course have to adjust our requests and things like that. But yeah, we could play around with this on Canary. I think be a good.
Yeah. And what would be? Sorry, I forgot in the beginning of this conversation. So what would be the benefit of doing that?
The thing is that memory between processes is shared on the Linux kernel. And if you start up several Puma workers, then more than half of the memory they're using are the same shared libraries that they are mapping into memory. And the Linux kernel figures this out and now it's okay, I don't really need to copy this into memory again. I can just use the same pages. And so if you see in the process listing 2 workers, let's say for Puma, and both using 1.2 gigabyte of memory, in reality, they just loaded, the first one loaded 1.2 gigabyte into memory, but the second one is using more than half of the pages that the other worker is using. So it's just adding, let's say, 500 megabytes more. And if we use more than 2 workers, that effect even is getting better, right? Because you are doing more using of shared pages.
I see. Okay.
So 4 workers is great. 8 is even better. So, and if we really are bound by memory of how many pods we can put into a node, then increasing the amount of workers could help to get more on one node. To figure out if that really helps a lot.
If we bump workers, is it always in multiples of 2? Can I go to 5?
Yeah, sure.
Okay, I was just curious.
I like doubling things, right? It's nice binary.
I like odd numbers. Let's go to 13.
Prime numbers, please. Yeah.
This is the unluckiest number as well. Henry, do you want to drop that on your suggestion for, like, you maybe got it under your 3A k8s workload tuning, but like if there's a more specific, like, Canary, like runners, workers change or whatever you want to like summarize that into, then go for it.
Yeah, I think we discussed this already, but I will try to put this in some issue. Yeah.
Awesome, thank you. I mean, it doesn't have to be an issue. You can just drop it in this doc, just so I can copy it into the spreadsheet. I'll try and just copy and paste over there. Awesome. Does that help you out, Scarbeck?
It does. It'll just be a slow process because we need to make a change, watch it happen, evaluate again, do another change. And the cycle time for that is just going to be kind of sluggish, which is fine because we have plenty of other work to be working on at the same time.
Yeah, absolutely. So like, I think it's fine if that bit, like, takes us some days. And you've got Henry around and Graham also. So if it's something which we pass through time zones as well, we can do that.
I would really love to get to a point where we're using custom metrics, and then instead of scaling because CPU went up, we're scaling because we know that we're going to have 3,000 users hitting our service at this moment
yeah.
in time. So we just say, hey, let's make sure we have enough coverage for that amount. But that would be more useful for Sidekick, I feel, but whatever.
And remind me, what is it that's blocking that?
Time and effort. I've never done it before. I don't know how to tie Prometheus into Kubernetes such that we could scale based on custom metrics. Yeah, and yeah, it's prioritization, really.
Okay.
I think that's a good long-term solution. Ideally, right now, we just need to get ourselves to a much better cost analysis situation, because right now we're using entirely too many nodes. We've effectively more than doubled the amount of nodes we're running for the same service, taking the same amount of traffic, and that's a little absurd. Let's solve for that first.
Yeah. Okay. Sounds like a good place to start. Awesome. Is there anything else anyone wants to bring up today? Yep. Okay. Awesome.
I think so.
Have a good rest of your day. All right. Take care.
Bye, everyone.
Bye.